Hello, my name is Javier Hernandez, and it's a great pleasure to be presenting our work entitled Guidelines for Assessing and Minimizing Risks of Emotion Recognition Applications, which is a collaboration with people from Microsoft Research, Harvard Kennedy School, and the MIT Media Lab. Back in 2015, Gartner presented the hype cycle of emerging technologies, which introduced for the very first time affective computing as one of those areas that were going to experience a peak of inflated expectations. And indeed, a few years later, we can confirm that there has been a significant shift in terms of agency that has moved from small research laboratory experiments to large-scale deployments. With that shift, we have also seen an increasing number of negative articles, usually highlighting some of the tensions and challenges of these technologies. However, we have also seen that there is a lot of confusion about how people understand and apply these technologies, which can elicit potential user harm. To help address this, the goal of this work is to better understand the challenges of applied emotion recognition and provide some guidance to help mitigate some of them. Studying the ethical implications of affective computing has been at the core of the field since the very beginning. Many of these studies usually focus on long-term hypothetical scenarios in which machines can already measure, understand, and simulate human emotions. For example, robots that simulate love, or governments that want to read the mind of their citizens. However, current commercial applications of emotion recognition are still very far from this. During the last few years, there has been an increased interest in examining the short-term impact of AI in general and emotion recognition in the general population in particular. Work by Stark and Hoy, for instance, highlighted that the selection of emotional models might have profound implications on the way end users use these systems. In addition, there has been an increased number of articles urging increased regulation and more multi-stakeholder collaboration. Similar debates have been taking place across different areas of AI as they were becoming more democratized. And to help alleviate these tensions, researchers have designed guidelines that help guide the development and applications in different areas, such as BCI or mental health. We could only find one document highlighting some potential guidelines in the context of emotion recognition, but the authors didn't provide much information about how they were designed or what was the background research. In any case, we see this work as complementary to that one. But given the importance of applications when designing these guidelines, we first review how emotion recognition is being used in real life. To do that, we started looking for commercial applications of emotion recognition on popular search engines, which had to meet three different conditions. First, they should describe the use of emotion recognition. Second, the application should take place in real-life settings. And third, the technology should be deployed in commercial settings. Considering these three conditions, some application areas quickly emerge. The first one is market research, in which emotion recognition has been widely used to monitor customer engagement and other types of responses. For example, people watching advertisements or analyzing reviews online. The second one is defense and security, in which these technologies are commonly used to monitor citizens or potential enemies to detect deceptive behaviors or potential threats. The third one is transportation, in which emotion recognition is used to monitor drivers or car passengers to promote safety in the case of angry or stressed drivers, as well as increase engagement in the context of self-driving cars. Next, human resources, in which these technologies are increasingly being used for pre-screening candidates or monitoring employees at a distance. Similarly, in educational settings, these technologies have been used to monitor students or detecting potential cheating behaviors during online exams, as well as skill training. Finally, there seems to be a quick increase in the number of mental health applications in which these technologies are used to detect the early onset and hopefully decrease of certain conditions like stress, loneliness, depression, and suicide. As we can see, emotion recognition is being applied in a wide variety of settings and for different purposes, which can inform the potential types of user harm. However, it's important to remember that emotion recognition is different than other areas of AI, and special considerations may be needed. While some of the challenges of emotion recognition have been already covered by prior work, let us review some of the main ones. First, the theory of human emotions is evolving, indicating that there is no unified theory of emotions that can explain all of its complexities. Second, human emotions are difficult to describe and label, limiting the quality of the labels used to train the systems. Third, collecting high-quality emotional data is difficult and expensive, which limits the availability of generalizable data. Fourth, due to the complexity of emotional experience, the language being used to describe emotion recognition systems seems to be oversimplified. Finally, emotions are being used to describe both feelings and external expressions, which blur the boundary between what should be private and what should be public, which may also depend on the expectations of each individual and different cultures. Considering both the previous applications and the unique challenges of emotion recognition, we can now start to identify and characterize potential user harms. To approach these, we borrow the types of harms model from Azure Services, which is being used to characterize harms of commercial AI systems and provides an accessible and easy to deploy characterization of user harms. Three of the main categories that are relevant to this work are denial of consequential services, risk of injury, and infringement of human rights. In the case of denial of consequential services, these technologies can prevent people from having equal access and services to opportunities when being used, for example, in job recruitment scenarios or when preselecting candidates for a mental health trial. In the long run, these may reinforce certain stereotypes, as unrepresented participants might not have access to these opportunities. The second one is the risk of injury, which might manifest in many different ways. For instance, it can be physical if users over-rely on safety mechanisms in the context of driving, or it can become emotional if users over-rely on digital therapists. Emotion recognition can also inflict injuries in the context of market research, when they are used to customize and personalize content, which can be highly addictive or polarizing. Finally, emotion recognition has also been used to openly analyze public figures during political debates, which can be damaging to their reputation. Finally, there is an infringement of human rights, which can happen also in many different forms. For instance, if end users have not consented to be monitored. These technologies can also facilitate indiscriminate use of predictive policing practices, such as those that may appear when monitoring suspicious behaviors in airports or cheating behaviors during online exams. When these technologies are being used by a group of people, they can also promote forced conformity or limit expression, as people might over-rely on these systems and try to modify their behaviors to adapt to the overall norm. As identifying these harms might not be immediately obvious in different applications, we then wanted to propose some guidelines that help inform their potential appearance. In particular, we came up with a set of application guidelines that we call the 4 Cs, as it's divided into 4 main areas that start with C. These areas are communication, consent, calibration, and contingency. For each of these areas, we came up with 3 different actionable guidelines to help mitigate and minimize the appearance of potential harms. The first area focuses on promoting responsible communication by ensuring that predictions are not handled as ground truth, system descriptions are described with enough granularity, and technology should be described with enough transparency. The second area focuses on promoting informed consent by ensuring that opt-in is provided before measurements are performed. Data handling is described to facilitate comprehension and awareness of the users. And consent facilitates freedom of choice without consequences. The third one focuses on promoting contextual calibration by ensuring that training data is representative of real-life data. Different sources of variance are accounted by the models, and end users can customize the system by providing feedback. Finally, the last one focuses on promoting comprehensive contingency by ensuring that personal data can be deleted by the user. Feedback channels are provided to the users, and shifts in data distribution are detected to ensure robustness. When applying these guidelines to different applications, we have observed that some strategies are a little bit more effective than others at addressing them. Some of these mitigation strategies include avoiding making assessments. For instance, a stress recognition system might not label the user experience as feeling stress, but instead it might indicate that changes have been detected and lets the user to make further interpretations based on the unique contextual and personal information. This could be particularly helpful when promoting responsible communication. The second strategy will involve adopting a private by default approach in which all data is assumed to be private unless specified by the user, which would help alleviate some of the challenges when providing informed consent. The third strategy involves adopting emotion as a form of expression rather than mind reading. For instance, emotion recognition systems that analyze face images might use labels that are more objective, such as a smile or brow furrow, than internal states such as happiness or confused. This approach is important when addressing communication and calibration guidelines. The last strategy involves adopting a human-computer collaboration approach in which the predictions are used to augment a human expert. For instance, in the case of an online proctoring service, a human expert could use the technology to more quickly browse through different video feeds. This approach could be particularly helpful when addressing guidelines around contingency. To summarize, we have observed a significant change of agency in emotion recognition tools, which has created a unique set of challenges. To help advance our understanding of this, we have overviewed current applications of emotion recognition, sources of challenges, and potential user harms. In addition, we have identified guidelines to assess risk and potential mitigation strategies. We have been using these guidelines internally, but there is still a need for more external validation. Also, these guidelines shouldn't be used as a standalone and recommend using some of the other guidelines which consider different application domains. When applying these guidelines, we also recommend addressing them in tandem to help facilitate better control over the different factors. However, this is not always possible due to the decentralization of the different factors, such as when companies provide emotion recognition APIs. To help minimize risk, we believe more collaboration across stakeholders is needed. Last but not least, it's important to know that the user harms and applications will continue to evolve, and hope future efforts will continue to extend the proposed guidelines according to the societal needs of the time. Finally, I want to thank you for your time and attention during this presentation and really hope we can engage in future conversations.